Sometimes, the quietest discoveries make the loudest echoes. It's the year 2025. Far beyond the orbit of Mars, a new visitor drifts into our solar system 3I Atlas. At first, astronomers call it a comet, just another frozen wanderer carrying whispers from the edge of the galaxy. But soon, the instruments at the W.M. Keck Observatory in Hawaii begin to speak a different language. Spectral lines flicker in patterns that should not exist. Reflections shimmer with compounds no natural body could ever hold. Professor Avi Loeb, calm but unflinching, looks at the data and says, asterisk. If it looks artificial, moves like it, and behaves like it, maybe it is. Asterisk. And just like that, the night sky feels different. You find yourself wondering, what if this isn't a rock, but a message? What if, somewhere in the darkness, intelligence moves quietly, choosing when and how to be seen? Tonight, you'll drift into that question, slowly, thoughtfully, as we follow the faint trail of 3I Atlas and ask whether the first true artifact of another civilization has finally come to visit us. Tuyệt vời! Dưới đây là phiên bản đã chỉnh lại hoàn toàn, bỏ tất cả ký tự và các ký hiệu hóa học, đồng thời giữ nguyên cảm xúc, nhịp văn và tính chính xác khoa học. Giọng văn được làm mượt hơn để khớp với phong cách Science for Sleep, chậm, sâu, gợi hình, dễ hiểu với khán giả Mỹ. In the deep silence of interstellar space, everything has a story written in light. Every comet, every fragment of rock, carries its own spectral fingerprint, a pattern of color that reveals what it's made of, how it was born, and where it has wandered. But in early 2025, when astronomers turned their telescopes toward a faint, fast-moving object named 3I Atlas, the light they received told a story that simply didn't make sense. The data from the W.M. Keck Observatory showed something no one expected. A strong signal of nickel tetracarbonyl, a compound known on Earth as one of the most toxic and industrially complex molecules we've ever created. It's a substance produced only in human laboratories and metallurgical plants formed when nickel combines with carbon monoxide under carefully controlled pressures and temperatures. In nature, it shouldn't exist. Not in the vacuum of space, not in the cold tails of comets, and certainly not drifting through interstellar dust. Yet, there it was. For scientists trained to see the universe as a system of order and physics, this was like hearing a human voice in the middle of a forest where no one should be speaking. Avi Loeb, professor of astrophysics at Harvard, once said during an interview, asterisk, when you find something that doesn't fit the script of nature, you have two choices: to ignore it or to ask why. Asterisk. And that is where the story of 3I Atlas begins to shift from astronomy to something closer to philosophy. Nickel tetracarbonyl is not merely unusual, it's almost impossible to form without deliberate engineering. On Earth, we use it to refine pure nickel from raw ores. The process demands precision, a balance of temperature, pressure, and gas concentration that can't arise spontaneously. It's dangerous, elegant, and unmistakably technological. For a comet to emit it, there would need to be active chemistry involving metallic nickel and carbon monoxide reacting under highly specific conditions, a process that cannot sustain itself in open space. Even more puzzling, the spectral data showed that the emission occurred without accompanying ion signatures. In nature, wherever you find nickel, you almost always find iron. They are cosmic siblings, born together in the explosions of dying stars and scattered through asteroids, planets, and comets. So why would 3I Atlas contain nickel in such a refined, isolated form bonded to carbon in a way that suggests precision? Some scientists argue that there might be a natural explanation waiting to be discovered, that under certain unknown interstellar conditions, perhaps a short-lived combination could form such compounds. But others, including Loeb, suggest that the simplest explanation might also be the boldest one. It might be artificial. He has often reminded his critics, asterisk, extraordinary claims require extraordinary evidence, but dismissing anomalies just because they're uncomfortable, that's not science. Asterisk, that sentence captures the tension of our time, a world caught between skepticism and wonder. When you look at the data yourself, you can imagine the scene in the observatory. The faint traces of light broken into 1,000 colored lines, each one whispering a story. Somewhere among those lines, a sharp peak, the signature of nickel tetracarbonyl, rises like a code from another mind. To most people, it's just a pattern. To others, it's the first glimmer of communication. The implications are staggering. If 3A Atlas is indeed emitting or venting nickel tetracarbonyl, it suggests machinery, heat control, containment, intention. Some engineers speculated that such a compound could be used as part of a propulsion or cooling system because it decomposes cleanly at moderate temperatures, releasing pure nickel metal and carbon monoxide gas. It's efficient, self-regulating, and perfect for high vacuum environments. Could this object be a probe that repairs or reconfigures itself using its own exhaust chemistry? Could it be an ancient craft whose systems still run not biological, but mechanical, drifting across centuries of light? Even to ask those questions is to step outside the comfort zone of conventional astronomy. But the data does not disappear. The light is real, the signal is repeatable. When 3I Atlas was first catalogued, astronomers thought it would be a footnote in the history of interstellar visitors like Oumuamua before it, a strange but harmless messenger from afar. Yet, every layer of analysis has deepened the mystery. Unlike typical comets, this object doesn't behave like a loose clump of ice and dust. It reflects sunlight with a metallic sheen. It doesn't outgas in random bursts, but in controlled, directional streams. And now, its chemistry reads like an engineer's blueprint. What does one do when the universe begins to speak in the language of industry? For decades, the idea of alien artifacts has been dismissed as fantasy, the territory of science fiction. But Loeb has insisted on something simpler, that we should follow the evidence wherever it leads. Asterisk. If you found a plastic bottle on the beach, asterisk, he said, asterisk, you wouldn't assume the ocean made it. You'd assume someone dropped it. Asterisk. By that logic, if we detect a compound that only industrial chemistry can create, perhaps it's not arrogance to imagine it came from technology. Perhaps it's humility, yet skepticism remains. Some scientists warn of instrumental noise, contamination, or misinterpretation of spectral lines. Others suggest it might be a transient molecule formed under radiation pressure, but no one has yet replicated the exact conditions needed to create nickel tetracarbonyl naturally in a comet's coma. In the quiet corners of the internet, the debate has become almost spiritual. People look up at the night sky and wonder whether, just beyond Mars, a machine drifts with purpose. Whether we're looking at the first fragment of someone else's civilization, a civilization that, like us, learned to shape metal and light. In the observatories, researchers keep recalibrating their instruments, cross-checking every variable. The numbers remain. The lines of nickel tetracarbonyl still stand, faint but persistent, like a note left behind. Avi Loeb once described science as asterisk, a dialogue with the universe. Asterisk. Perhaps, this time, the universe is whispering back. If 3I Atlas truly carries artificial traces, it changes everything, not because it proves that aliens exist, but because it proves that our understanding of natural is incomplete. It means the cosmos might be a workshop, not just a wilderness. It means intelligence could be common enough to leave fingerprints in chemistry itself. And perhaps that's the quiet miracle here. The discovery doesn't shout. It doesn't announce itself in thunder or light. It hides in a molecule invisible to our eyes but impossible to ignore. Nickel tetracarbonyl. A poison, a tool, a clue. Somewhere in that silence, you can almost imagine the hum of machinery. Ancient, distant, methodical, still performing the task it was built to do. Maybe maintenance, maybe observation, maybe something far beyond our understanding. For now, all we have is light. Light and the courage to ask what it means. As Loeb said, asterisk, the universe is not obligated to make sense to us, but it rewards those who listen. Asterisk. And so, we listen to the spectrum, to the stars, and to the strange, shimmering signal of 3I Atlas. a voice from the dark, speaking in the dialect of impossible chemistry. Bạn có muốn mình chuyển thể đoạn này thành script đọc chậm, cho giọng voice over, có ngắt nghỉ, nhịp hơi và khoảng lặng phù hợp với Signs for Sleep? Nếu có, mình sẽ chia đoạn theo hơi thở và âm nhạc nền để bạn dùng trực tiếp cho video. And so, after the strange discovery of a man-made chemical shimmering in the darkness, the mystery of 3I Atlas deepened. Light had already told us what this traveler was made of. Now, its movement, its behavior, began to tell us what it wanted. In the language of celestial mechanics, comets are predictable creatures. They fall toward the sun, warm up, and breathe outward. The heat releases gases that stream away from the sunlight, forming long, glowing tails that always point outward, away from the star's fierce radiation. It is one of the simplest, most elegant laws of orbital behavior, but 3I Atlas refused to obey. When telescopes tracked its rotation, astronomers saw jets of material not pushing away from the sun, but firing toward it streams of carbon dioxide gas directed inward, as if the object was steering against gravity rather than yielding to it. Nearly 87% of the outflow consisted of carbon dioxide, an unusual ratio that hinted at control, not chaos. It was as though something aboard the object understood how to use thrust. Imagine it, a dark body, cold and distant, exhaling toward the light instead of from it. The image defies instinct. In every comet we have ever known, the sun is an engine of destruction, peeling away ice and dust in great luminous arcs. But here, the sun seemed to be the target, not the source of escape. Avi Loeb once remarked, nature doesn't cheat when it looks like it's breaking its own rules. It's telling us that we're missing something. That thought lingered in every data file, every simulation, every late-night conversation in the observatories. If 3I Atlas were a natural comet, the physics would demand that heating occur on its sun-facing side, creating jets that push the body outward. Instead, scientists measured plumes that originated in cold regions, far from direct radiation. The pattern looked less like sublimation and more like propulsion, as if the object were using carefully directed bursts of gas to manage its trajectory. The jets formed geometric patterns, evenly spaced, consistent over time. No random fractures, no chaotic eruptions. Each emission aligned along a precise vector, and the overall motion stabilized rather than spun out of control. It was behavior that suggested calculation. To understand how wrong this is, picture an ordinary comet as a campfire. The hotter one side gets, the more violently it spits out sparks. That chaos drives the comet to tumble, wobble, change direction. But 3I Atlas did the opposite. It steadied itself. Its light curve flattened, its spin slowed. It seemed to know where to point. And then came the second impossibility, temperature. In the data collected from both Keck and the European Southern Observatory, the surface of 3I Atlas appeared far too cold for its distance from the sunday. By the laws of thermodynamics, it should have been glowing, its ices boiling off in violent streams. Instead, it absorbed sunlight without warming, maintaining a temperature more suited to the outer Kuiper belt than the inner solar system. One scientist described it as a person sweating in a freezer. The analogy spread quickly because it captured the absurdity of the observation. How could an object emit jets of gas while staying colder than the environment that should be melting it? There are natural explanations, of course. Some proposed that the gas vents might come from internal pressure, or that reflective materials on the surface could be bouncing sunlight away. Others spoke of exotic ices or insulating dust layers. But none of those models fit both puzzles at once, the directed jets and the freezing temperature. Avi Loeb suggested another possibility. If you see an object accelerating in a way that can't be explained by gravity or heat, he said, the simplest explanation is that it's being pushed, perhaps intentionally. To many, that sounded outrageous. Yet, as more data arrived, the outrage gave way to unease, because every new frame, every new reading, seemed to support the idea that this wasn't random. The plume directions remained consistent over weeks. The object's trajectory showed subtle corrections, tiny deviations that mirrored the kind of mid-course adjustments engineers make when guiding spacecraft. It was as if the comet were alive with its own navigation system. In the quiet of scientific discussion boards, a few researchers began to whisper about propulsion. Carbon dioxide, after all, is an efficient propellant in vacuum when properly heated and released through a nozzle. It provides a steady, clean thrust. Could 3I Atlas be venting gas deliberately, either as a form of correction or communication? Some imagined a forgotten probe, ancient and damaged, still following instructions written long before humanity learned to dream of rockets. Others envisioned a self-assembling device, a seed of technology that uses simple chemistry to steer itself between stars. Of course, there are skeptics. Many, and rightly so. The scientific method demands resistance to wonder, yet the resistance only sharpens the mystery, because while the theories multiply, the facts remain fixed. Jets toward the sun, not away. A temperature too cold to explain those jets. A pattern too organized to dismiss as accident. To Loeb, the situation echoed what happened with Oumuamua years earlier. He had argued then that we must not be afraid of extraordinary interpretations. Asterisk. If we never entertain the unusual, asterisk, he said, asterisk, we risk mistaking intelligence for coincidence. Asterisk. That philosophy divides the field. Some call it visionary, others call it reckless, but it keeps the conversation alive, and perhaps that is the point, because the behavior of 3I Atlas is not just a scientific anomaly, it is a mirror. It reflects our own hesitation to see the universe as something more than a collection of rocks and radiation. It asks whether technology could be as common as chemistry, whether intelligence could leave traces not in words but in motion. If a comet can act like a ship, what else have we misread? For now, the object continues its journey, moving through the inner system in silence. The sun glows before it, and still it breathes toward the light. To the instruments, it's only data. To the human imagination, it's something else, the possibility that we are watching a machine, ancient and indifferent, performing a maneuver it has done 1,000 times before. At the end of one late-night session, an astronomer wrote in his log, asterisk, the object does not behave, it performs. Asterisk. That line was never meant for the public, but it captures everything. When a comet defies physics, it's not just an object that changes, it's us. We begin to see not only what is, but what could be. And somewhere in that space between certainty and wonder, 3I Atlas keeps drifting cold, deliberate, and still whispering through its impossible breath. The deeper we looked, the stranger it became. After the impossible chemistry and the defiant movement, the story of 3I Atlas was no longer confined to the equations of astrophysics. It began to spill into something human. The politics of information, the boundaries of secrecy, and the question of who gets to decide what we are ready to see. As the object swept past Mars on October 3rd, 2025, humanity had a rare opportunity. 7 orbiters from NASA, the European Space Agency, China, and the United Arab Emirates were perfectly positioned to capture the moment. The alignment was extraordinary, the timing almost poetic, a cosmic rendezvous between worlds. For weeks, anticipation built across observatories, forums, and newsrooms. Scientists, students, and dreamers all waited for the first clear images of an interstellar visitor flying by another planet. And then, the pictures arrived. A blur, a smudge of light, a single grey pixel that could have been anything, a trick of exposure, a speck of dust on the lens, or maybe, as the official report said, an object of insufficient resolution to determine structure. At first, the disappointment was simple. Cameras malfunction. Timing errors happen. But then came the questions. Why did the world's most advanced imaging systems, capable of reading a newspaper left on Mars's surface, suddenly produce nothing? Why was the high-resolution imaging science experiment The high-rise camera aboard NASA's Mars Reconnaissance Orbiter silent. When asked, the agency gave a brief statement. Due to a government shutdown, data release had been delayed. That explanation should have ended the discussion, but it didn't, because all the other agencies, from ESA to CNSA to the UAE's Hope Orbiter, went quiet at the same time. No images, no updates, no press briefings. It was as if, for the first time in decades, space agencies across political lines had agreed on the same thing: to say nothing. Avi Loeb, speaking in an interview shortly after, said calmly, "Silence is not a scientific answer. He didn't accuse anyone of a cover-up. He didn't have to." His words carried the weight of curiosity. That same quiet insistence that the universe should be transparent to all who look. What followed was a wave of speculation that rippled far beyond the academic world. Amateur astronomers began scouring data from open-access observatories, searching for independent confirmation. Online forums filled with theories. Some believed the images were being reviewed for national security reasons. Others thought something in those photographs defied ordinary explanation. It is easy to dismiss such talk as rumor, yet the timing was peculiar. On the same day the high-rise data went missing, a temporary suspension appeared on several NASA image servers. The official note cited scheduled maintenance. And when those systems came back online, the public index showed a gap exactly where the Atlas flyby should have been logged. Coincidence? Maybe. But coincidences, like comets, follow orbits of their own. To understand why this silence felt so heavy, you have to remember what was at stake. 3. Atlas was not just another comet. Its chemical signature broke the rules of natural formation. Its propulsion-like jets suggested intention. A clear image, a single frame might have confirmed or destroyed those ideas forever. Instead, the picture was withheld, and in the vacuum of truth, imagination filled the space. A researcher at the European Southern Observatory, who requested anonymity, later said, "If those images show what we think they show, it would change not just our science, but our history." That statement, leaked and later denied, only deepened the mystery. The high-rise team, known for publishing breathtaking details of Martian dunes, craters, and rover tracks, suddenly went silent on social media. Their last post before the data blackout read simply, "Mars is full of surprises." After that, nothing. It is here, perhaps, that the story of 3I Atlas becomes less about astronomy and more about humanity itself, about the delicate balance between discovery and control. What happens when evidence challenges not our instruments, but our sense of reality? When a photograph could redefine the relationship between Earth and everything beyond it, who holds the right to decide whether we're ready to see? Loeb has always warned against such gatekeeping. Science. He once said, is not a spectator sport. If the universe is playing a game, we are all on the field. Those words resonate now, as people across the world scroll through grainy re-uploads of what might be enhanced leaks, each claiming to reveal the truth. Some images show angular shadows, others depict geometric forms hovering against the red haze of Mars. Most are hoaxes, some obvious, others beautifully convincing. But hidden among them are frames that seem real enough to unsettle even trained eyes. Could the object have been metallic? Did it reflect sunlight in ways inconsistent with rock or ice? Could its surface have structure panels, symmetry, and intentional design? No one outside those locked data rooms can say for sure. But perhaps the most curious thing of all is how coordinated the silence has been. Space exploration is often marked by competition, not cooperation. Yet here, across agencies that rarely share secrets, an agreement seemed to emerge. Release nothing, at least not yet. Officially, the reason remains bureaucratic. Unofficially, It feels like something else. In the absence of proof, people listen differently. They listen to tone, to hesitation, to what isn't said, and in those silences, new possibilities echo louder than any confirmed fact. The incident has reignited debates about the ownership of knowledge. Should data gathered by publicly funded missions belong to everyone, or only to the few who decide when it's safe to publish? Should science ever be allowed to hide behind politics? Loeb's response was measured, almost weary. Asterisk. Transparency is not a privilege. Asterisk. He said. Asterisk. It's a responsibility. Asterisk. Perhaps the withheld images are mundane. Perhaps they show nothing more than a blur, a rock, passing by a red planet. But perhaps they reveal a geometry we cannot explain, a structure that challenges the comfort of randomness, a glimpse of something built, not born. Until the images are released, 3I Atlas remains suspended between myth and mathematics, both real and imagined. It is the Schrödinger's comet of our time, existing in two states at once, an ordinary object of ice and dust, and a crafted artifact drifting through alien silence. As night falls on the deserts of Earth, telescopes continue to watch. They trace the path of 3I Atlas as it slips behind the sun, where cameras cannot follow. The data stream fades, the chatter quiets, and somewhere in that growing silence, humanity waits not for proof, but for permission. Because sometimes, the greatest mystery in science isn't what the universe hides from us, it's what we hide from ourselves. The silence did not stop them. When the official channels went quiet, ordinary people began to listen more closely, and when no images were released, they decided to make their own. It started small, a handful of amateur astronomers on online forums sharing what little data they could find. Bits of open telemetry, low-resolution images from Mars orbiters, faint radio readings scraped from public observatories. They were not professionals, but they were patient, curious, and determined. From that quiet determination, a movement began to take shape. They called it, informally, the decoding. Using artificial intelligence tools and open-source image processing software, these volunteers began enhancing every pixel of the few blurred images of 3I Atlas that had been made public. They stacked frames, refined contrasts, and ran adaptive algorithms once reserved for deep space research. What emerged, at first, was noise, then outlines, and finally, something far stranger. A shape, not round, not random, but geometric. Some described it as triangular, with crisp edges and a symmetry that looked too deliberate to be natural. Others saw block-like forms, patterns of light and shadow that seemed mechanical. It was easy, at first, to dismiss these results as wishful thinking, the human brain finding order in chaos. But as more independent users replicated the same shapes using different methods, curiosity turned to unease. Could it be that the object hiding behind NASA's silence actually had structure? Avi Loeb, when asked about the citizen-led decoding movement, answered simply, asterisk, science belongs to everyone who asks questions, asterisk. That single sentence electrified the online community. It was a quiet validation, a reminder that curiosity itself is not a conspiracy. Within weeks, forums across Reddit, X, and independent astronomy networks filled with new uploads. Enhanced imagery, spectral analyses, even 3D models reconstructed from shadow data. Some of the results were clumsy, others breathtakingly sophisticated. One sequence appeared to show panels or surfaces with uniform reflectivity, suggesting engineered materials. Another showed sharp angles, like ribs or struts, casting precise shadows onto the Martian atmosphere. Then, without warning, the posts began to vanish. At first, people blamed copyright claims or simple moderation errors, but the pattern was too consistent to ignore. Entire threads disappeared within hours of being published. Videos analyzing the 3I Atlas flyby were quietly demoted in search results, their view counts frozen or reset. Even Loeb's interviews began showing strange buffering issues on streaming platforms. It felt as though an invisible hand was reaching across the internet, erasing the conversation before it could take root. A software engineer from Arizona, one of the first to build an independent database of the citizen reconstructions, described the experience this way. Asterisk. It's like trying to paint on water. Every time we draw a picture, the surface ripples and the image is gone. Asterisk. Soon, new rumors began to spread that social media algorithms were being tuned to suppress anything related to 3I Atlas. Keywords like interstellar object, Atlas geometry, and Mars anomaly began to trigger limited visibility. The more people tried to discuss it, the harder it became to find. Some laughed it off as paranoia. Others compared it to historical precedents, times when discoveries challenged the status quo and were quietly sidelined. Whether intentional or not, the effect was the same. A growing feeling that something extraordinary was being hidden in plain sight. For many, this wasn't just about science anymore. It was about ownership of truth in the digital age. In an era where artificial intelligence can magnify both clarity and deception, who gets to decide what we're allowed to see? Loeb's words surfaced again in podcasts and videos. Asterisk. If we stop asking questions out of fear of being wrong, we stop being human. Asterisk. And so, the decoding movement evolved. Instead of vanishing, it went underground, migrating to encrypted forums, private data repositories, and decentralized servers. Citizen scientists began sharing their findings through peer-to-peer links, using anonymous file-sharing systems to bypass algorithms. It was no longer just about 3I Atlas. It had become a quiet rebellion against the gatekeeping of discovery itself. Across the world, night sky enthusiasts kept scanning the heavens. Some used backyard telescopes fitted with 3D printed mounts. Others coded new AI filters designed to reconstruct missing data from fragments. Each image felt like a protest, a statement that curiosity would not be silenced. In many ways, this digital uprising echoed the very essence of astronomy, the desire to look beyond what is given, to search for what might be true. It was messy, chaotic, but deeply human. There's something profoundly poetic about that millions of people, connected only by curiosity, staring into the same void and asking the same question. Asterisk. What are they not showing us? Asterisk. Not everyone believed in the suppression theory, of course. Many professionals urged caution, reminding the public that algorithms often behave unpredictably, that content moderation is automated, not conspiratorial. But even those voices admitted one unsettling fact. The data blackout was real. The highest resolution images of the flyby still hadn't been released, months after the event. And so, in the absence of truth, imagination once again took the lead. Some of the AI-enhanced images began to circulate with eerie consistency depictions of geometric silhouettes glinting near the Martian limb, structures resembling scaffolds or antennae. The quality varied, but the emotional impact was undeniable. In living rooms and late-night YouTube sessions, people stared at these grainy reconstructions with the same sense of awe and dread that generations once felt looking at the first photographs of Earth from space. It wasn't proof, but it was possibility, and sometimes that's even more powerful. Avi Loeb later commented in an interview, asterisk, if curiosity becomes dangerous, we've already lost the spirit of science. Asterisk. That line struck a chord across the internet. It wasn't an accusation, it was an invitation to keep looking, to keep questioning, even when the answers make the world uncomfortable. The movement continues quietly today, scattered but alive. Thousands of images, refined and reprocessed, circulate in encrypted archives and private drives. Some of them, if genuine, could rewrite what we know about the boundaries between the natural and the made. Others are nothing more than digital mirages, but all of them, together, form a chorus of human persistence, a refusal to accept silence in the face of wonder. From the empty corridors of observatories to the glowing screens of ordinary people, the story of 3I Atlas has become something larger than science. It's become a mirror reflecting our deepest question. Do we still believe that the truth belongs to everyone? In the end, The real mystery may not be what's hidden on those images, but why so many are afraid of us finding out. Because the moment humanity stops looking up, stops asking, the sky itself becomes smaller. And perhaps that, more than any interstellar secret, is what 3I Atlas came to remind us of. The movement of curiosity had become unstoppable. After the public's decoding efforts, after the vanished threads and blurred truths, one voice began to rise above the noise, calm, steady, and unwavering. It belonged to a man who had been here before, Avi Loeb. To some, he is a visionary. To others, a provocateur. But in the story of 3I Atlas, he stands as something rarer. A scientist unafraid to ask questions that make the world uncomfortable. It wasn't the first time Loeb had stepped into controversy. In 2017, when the interstellar visitor known as Oumuamua crossed our solar system, most astronomers classified it as a rock, a relic of some distant system. Loeb didn't. He looked at its shape, its motion, its strange acceleration, and said the words that would echo across headlines. Asterisk. It could be artificial. Asterisk. That sentence, simple and heretical, turned him into both a lightning rod and a beacon. He wasn't claiming certainty, he was demanding curiosity. And now, in 2025, the arrival of 3I Atlas has drawn him back into the storm. To Loeb, the new object is not just another interstellar traveler, it's a continuation of a pattern, a whisper from the same unknown intelligence. In recent interviews, he has been careful, deliberate, but unmistakably bold. Asterisk. We are not alone in the universe. Asterisk. He said, asterisk. But we might be alone in our willingness to notice. Asterisk. He then laid out 7 anomalies, 7 reasons why 3I Atlas cannot easily be explained as a natural object. Each, by itself, might be dismissed. Together, they form a chain too coherent to ignore. The first anomaly, its orbit. Unlike random interstellar debris, 3I Atlas travels on a trajectory that lies almost perfectly along the plane of Earth's orbit. That alignment is astronomically unlikely. The odds of such precision occurring by chance are vanishingly small, like tossing a coin across a football field and having it land balanced on its edge. To Loeb, this isn't luck, it's intent. The second, the chemical fingerprint. We've already seen how its spectrum revealed nickel tetracarbonyl, an industrial compound found only in engineered processes. That discovery, combined with its strange metallic reflectivity, suggests not a natural body, but something manufactured, a possibility that forces science to confront a boundary it has long avoided. The third, its temperature. By every known physical model, the object should be much warmer, especially as it nears the sunday. Instead, it remains astonishingly cold. Cooling mechanisms of that efficiency do not exist in comets or asteroids, but they do exist in engineered systems, radiative panels, thermal shields, self-regulating alloys. The fourth, its propulsion. We've seen how 3I Atlas emits jets toward the sun, as though it were adjusting its path rather than reacting to heat. The directionality, consistency, and timing of these jets resemble the controlled exhaust of a maneuvering system. Loeb has put it simply, asterisk. If something behaves like a spacecraft, it's worth considering that it might be one. Asterisk. The fifth anomaly, its mass. Calculations based on its trajectory suggest that 3I Atlas is far denser than expected, heavier than ice, heavier even than iron-rich rock. It moves with the gravity of something compact, perhaps metallic. No known comet carries that much mass, without showing clear gravitational disruptions to nearby objects. Yet, 3I Atlas glides smoothly, as though its density were balanced by design. The sixth anomaly, its coordinates. When plotted against historic astronomical data, its path seems to intersect, almost eerily, with the coordinates of the famous WOW signal detected in 1977. That mysterious radio transmission that lasted just 72 seconds, never repeated, never explained. The connection might be coincidence, but coincidence has limits. And finally, the seventh, timing. 3. I, Atlas, disappeared behind the sun precisely when Earth-based observatories were least able to observe it. Its period of invisibility, calculated to the day, aligned perfectly with the predicted window of the sun's interference. For Loeb, this wasn't mere luck. Asterisk. If it were a mission, asterisk, he said, asterisk. This would be the perfect maneuver to avoid detection. Asterisk. Each of these points, taken individually, might be explained away statistical anomalies, unknown physics, data noise. But taken together, they form what Loeb calls asterisk, a pattern of intention. Asterisk. His insistence on openness has not made him popular in every scientific circle. Some accuse him of sensationalism, of blurring the line between science and speculation. But Loeb's response remains steady. Asterisk. The role of science is not to protect comfort. It is to pursue truth, wherever it leads. Asterisk. He argues that dismissing unusual evidence simply because it challenges our worldview is a betrayal of the scientific method itself. If anything, he believes, the discomfort is proof that the question is worth asking, and yet there's something deeply human in his persistence. He doesn't shout, he doesn't dramatize. He simply observes and invites others to do the same. You can hear it in his tone when he speaks about 3i Atlas. There's no arrogance, no desperation, only quiet curiosity. He talks not as a man trying to prove aliens exist, but as one trying to remind humanity of how little it knows. Asterisk. The sky is a message board. Asterisk, he once said. Asterisk. And most of us stopped reading. Asterisk. In that humility lies his power. Because in an age when institutions grow cautious and public attention shifts toward the safe and the certain, Loeb stands for something rare. The courage to stay uncomfortable. He has proposed a new initiative, a global network of open-access telescopes designed to record future interstellar visitors with transparency, data sharing, and real-time analysis. His goal is simple: no more missing images, no more hidden data. If the universe sends us another messenger, humanity should meet it together under open skies. That idea, radical in its simplicity, echoes the spirit of Galileo and Carl Sagan's scientists who understood that wonder is not the opposite of reason, but its beginning. Still, the resistance continues. Critics write op-eds, funding boards hesitate, and social media mocks his theories. But for every skeptic, there are thousands of listeners leaning closer, not because they are convinced, but because he makes them feel that curiosity still matters. In one of his most quoted talks, Loeb said, asterisk, "We might not be the smartest kids on the cosmic block, and that's okay. What matters is that we're willing to learn." Asterisk. And perhaps that is what truly unsettles his critics. Not the possibility of extraterrestrial intelligence, but the reminder that humility is the price of discovery. As 3i Atlas continues to drift beyond Mars, Loeb's 7 anomalies hang in the air like unanswered questions, glinting in the dark. Whether they point to technology or to a new branch of physics, no one can yet say. But his voice ensures that the question will not fade into silence, because in the end, every great leap in understanding begins with one scientist willing to stand alone, to risk being wrong in order to keep the door to wonder open. Avi Loeb has become that scientist not because he claims to know the truth, but because he dares to ask what happens if the truth is bigger than we imagined. And maybe, just maybe, that's what the universe has been waiting for all along. Not belief, not denial, but attention. For weeks after Avi Loeb's statements, the conversation around 3i Atlas grew louder, sharper, and more divided. Some dismissed his 7 anomalies as coincidence. Others saw them as the beginning of something extraordinary. But then, as debate turned into fatigue, a new kind of evidence began to surface not from laboratories or agencies, but from the skies themselves. Because just after 3i Atlas swept past Mars, something started to happen there. At first, it was a whisper on astronomy message boards. A few amateur observers, monitoring Mars through independent radio telescopes, noticed faint signals between 400 and 800 megahertz pulses, repeating every 3.2 seconds. They didn't sound like cosmic background noise or the usual planetary emissions. They were rhythmic, organized, deliberate, and then came the images. High-powered backyard telescopes, aided by adaptive optics and AI-driven stabilization, began picking up strange reflections in Martian orbit. They weren't meteors or known satellites. They appeared to be stationary for hours at a time, then move suddenly in straight lines before stopping again. Some looked like tiny geometric forms, triangles, rectangles, objects with defined symmetry glinting just above the planet's thin atmosphere. Within days, the community began to connect the dots. The radio pulses, the moving reflections, the timing, all of it began immediately after the interstellar object's flyby. Had 3I Atlas done something as it passed? Avi Loeb, ever careful with his words, offered a measured comment during a televised interview. Asterisk. If technology exists beyond Earth, it will not announce itself with fireworks. It will reveal itself through patterns we can't explain. Asterisk. That sentence became a touchstone for what followed, because the patterns kept coming. Radar monitoring of Phobos, the larger of Mars's two moons, showed unusual fluctuations in reflectivity, as if its surface were changing texture. Some observers even claimed to detect small, block-like objects moving near its shadow, altering position between observations. At first, scientists attributed it to data noise or micrometeor impacts. But when several independent stations reported the same coordinates, the coincidence became harder to dismiss. It was as though something or someone was moving material around the Martian system. Those who believed in the artificial origin of 3I Atlas saw this as the next step. They argued that if the object was indeed a probe, perhaps it had released smaller devices, tools, drones, or seeds of machinery into orbit around Mars. The idea sounded fantastic, almost mythic, but the evidence was persistent. The signals were measurable. The geometry was visible. In scientific forums, the hypothesis soon gained a name. Asterisk. The Martian infrastructure theory. Asterisk. According to its supporters, 3I Atlas might have been more than a traveler. It might have been a constructor deploying a network of self-replicating systems designed to harvest local material, build structures, or establish communication beacons. It sounds like science fiction, yet history is full of technologies that began that way. When questioned about the possibility, Loeb responded not with denial, but with humility. Asterisk. We don't know what's possible for civilizations older than ours. Asterisk, he said. Asterisk. We only know what we can imagine, and that's a very small window. Asterisk. On social media, satellite images of Mars began circulating, some real, some manipulated, all feeding the growing curiosity. Enthusiasts pointed out sharp-edged shadows near the equator, formations that seemed to shift subtly between orbital passes. NASA's official response was reserved. No anomalous structures had been confirmed, and all apparent changes were attributed to variations in lighting and dust storms. But the public wasn't convinced. The timing was too perfect. The flyby, the silence, and now this Mars behaving like a construction site glimpsed from across the void. In many ways, it was the perfect stage. Mars has always been humanity's mirror, close enough to feel familiar, distant enough to hold secrets. Every generation projects its own hopes and fears onto that red world. In the 19th century, we imagined canals. In the 20th, we dreamed of colonies. Now, in the 21st, we whisper about machines. Yet behind the sensationalism lies a profound question. What if we are not witnessing invasion, but continuity? What if Mars has always been part of a network, a way station in a chain of intelligence that predates us? Some theorists went further, suggesting that 3I Atlas may not have built anything new at all. Perhaps it reactivated something old, structures buried in the dust, remnants of a prior visitation, awakening as their maker returned. It's speculation, yes. But speculation is where science begins. Avi Loeb's stance remains consistent. Asterisk. We are explorers of evidence. Asterisk, he said. Asterisk. And evidence does not care whether we believe it or not. Asterisk. That statement captures the essence of this moment. Because regardless of what the objects near Mars truly are, instruments, debris, or mirages, the reaction of humanity tells us something equally important. We are desperate to connect the dots, to make meaning of the unknown. Our telescopes reach farther than ever, but so do our imaginations. And perhaps that's what the universe expects of us. Still, the data keeps arriving. Radio telescopes in Chile, Italy, and Japan have all reported intermittent pulses near the same frequency bands. The rhythm remains consistent, 3.2 seconds, steady, like a heartbeat in the dark. Engineers who analyzed the signal structure noted that its timing was too regular to be random, yet too imperfect to be digital interference. Is it a transmission? A mechanical oscillation? Or the echo of natural resonance amplified by geometry we do not yet understand? Whatever it is, it seems tethered to Mars. Somewhere above that silent red desert, something moves invisible to the naked eye, detectable only through its rhythm. Perhaps it is nothing. Perhaps it is everything. And if it truly is building, as some claim, what is it building for? Loeb once said, asterisk, the universe is not a museum, it's a workshop. Asterisk. The phrase has since taken on new meaning. If 3I Atlas is part of that cosmic workshop, then maybe Mars is one of its workbenches, a place where time and technology meet in ways we cannot yet perceive. For now, astronomers continue to watch. They map the shifting points of light, listen to the repeating pulses, and record every anomaly with patience. Whether it proves to be evidence of alien engineering or just a new kind of natural phenomenon, it forces us to expand our imagination to stretch science until it meets wonder. And perhaps that is the greatest construction of all, not the one happening near Mars, but the one taking place within us. Because each mystery we encounter in the cosmos builds something new inside the human mind, a framework of curiosity, a scaffolding of awe. It reminds us that discovery is not an act of possession, but of participation. Maybe, somewhere above Mars, something really is building. But down here, so are we building the courage to look at the unknown and to keep asking, even when the answers seem too large to hold. The idea that something might be building on Mars had shaken even the most disciplined minds. Astronomers who once laughed at speculation now spoke more softly. Data analysts began to leave longer pauses in their reports. Even the skeptics, those who prided themselves on logic alone, started looking twice at every image, because deep down, everyone understood one simple fact. The story wasn't over. 3. Atlas had vanished behind the Sunday. For weeks, it had been unobservable, hidden by the blinding light of our nearest star, a curtain of radiation shielding whatever truth might be unfolding beyond it. In this silence, all that remained was anticipation. Instruments waited, scientists waited, humanity waited, and now, as October 2025 wanes and November approaches, the world holds its breath. Because when the object re-emerges from behind the sun, everything will depend on what it does next. 2 possibilities, 2 futures. If 3I Atlas continues along its predicted path, stable, passive, unchanging, then this story will fade into the archives of misunderstood anomalies, a curious episode, a case study for astrophysics, a whisper that once tried to sound like a voice. But if it does not, if it shifts course, accelerates, or emits even the faintest sign of control, then the conversation changes forever. That would mean, unequivocally, that something intelligent is at work within our solar system. As Avi Loeb said recently in an interview, asterisk, nature doesn't take instructions, only technology does. Asterisk. The simplicity of that statement hides its enormity, because to watch a celestial object behave intentionally is to witness a boundary collapse between the natural and the engineered, between the observed and the observing. The world's observatories are preparing for this moment as if awaiting an eclipse of history itself. In Hawaii, telescopes have been recalibrated to catch the first glint of reflected sunlight from the object's surface. In Chile, high-frequency arrays stand ready to monitor any anomalous signals. In Massachusetts, Loeb's team at Harvard has coordinated with international partners for simultaneous observation, not just in the visible spectrum, but across radio, infrared, and ultraviolet. Every lens, every antenna, is aimed at a single point that does not yet exist in the dawn sky. And beyond the science, there is the psychology. For months, the human imagination has stretched to contain what it cannot prove. Some envision a dormant probe awakening, others fear an ancient machine returning. But beneath the speculation lies something far simpler and perhaps more profound. The hope that we are not alone, and the fear that we might be. It's a paradox that has always defined our search for the unknown. We dream of company among the stars, yet tremble at the thought of being seen. Loeb understands that duality well. Asterisk. Discovery is not about comfort. Asterisk. He said. Asterisk. It's about courage. The universe rewards those who pay attention. Asterisk. Right now, attention is all we have. Across social media, countdowns have begun not from agencies or scientists, but from ordinary people. Amateur astronomers, podcasters, and night sky enthusiasts have turned November into something like a vigil. They track the projected coordinates, trade updates, and speak in tones usually reserved for eclipses or meteor showers. But this time, it's not beauty they're waiting for, it's proof. In laboratories, computers hum with simulations of every possible outcome. If 3I Atlas stays on course, it will exit the inner solar system by late December, fading into the black between worlds. But if it alters direction even by a fraction of a degree, it will indicate propulsion, decision, control. And that, Loeb has argued, would change not only astronomy, but civilization itself. Asterisk. The moment we confirm technology beyond Earth. Asterisk, he said. Asterisk. We stop being the center of the story. Asterisk. It's a humbling thought. For centuries, humanity has built its identity on uniqueness, on the idea that intelligence was ours alone. To lose that exclusivity is not to lose importance, but to gain perspective. It would mean that intelligence is not a miracle, but a pattern, something the universe does when it has enough time and silence. And yet, there's another layer of fear hidden beneath that possibility. Because what if 3I Atlas is not just intelligent, but active? What if its silence has been deliberate, a waiting game, an observation of its own? If the object truly changes trajectory in November, the next question will not be times if times it's alive, but times why times it's here. For now, every hypothesis is on the table. Some think it's an ancient probe, perhaps from a civilization that existed millions of years ago, still carrying out its mission long after its creators are gone. Others suggest it could be an autonomous system, self-replicating, adaptive, exploring. A few imagine it as a kind of cosmic archaeologist, studying us the way we study fossils. Whatever it is, its next move will speak louder than any press conference. The tension is global. Observatories coordinate in encrypted channels. Media outlets prepare emergency segments in case confirmation comes suddenly. Even governments are watching closely, though few will admit it. The possibility of contact, even indirect, is not just a scientific event, it's a geopolitical one. And yet, amid all this noise, there's something beautifully quiet about the waiting. It feels like standing on a dark beach before sunrise, listening to the tide breathe, knowing that light is coming but not what it will reveal. Loeb himself seems both calm and restless. In a recent lecture, he said, asterisk, when you stare into the unknown long enough, you realize the unknown is staring back. Asterisk, that idea lingers. Because maybe 3I Atlas isn't a visitor at all. Maybe it's a mirror reflecting our own need to understand, to connect, to believe that intelligence is not an accident of Earth, but a language written into the stars. As November dawns, telescopes will open like eyes across the night. In those first moments when 3I Atlas emerges from behind the sun, the world may find its answer. Maybe it will glide along its expected path, indifferent and silent, and the story will close with a sigh of relief. Or maybe, just maybe, it will tilt, slow, shift, or shine with an intentional glimmer, and everything we know will change. Either way, the universe will have spoken, And perhaps the most extraordinary thing isn't whether it's natural or artificial, but that we were here awake, listening, and ready to hear it. Because the truth about 3i Atlas, whatever it turns out to be, has already done something miraculous. It has made us look up again. It has reminded us that even in the age of noise and certainty, there is still room for mystery, and that somewhere, hidden behind the light of the sun, the next chapter of human understanding is waiting to begin. The world waits beneath a silent sky. As November unfolds, telescopes hum and data streams flow, but the question remains suspended in darkness. What will 3i Atlas do next? It is a fragile moment, that quiet balance between possibility and proof. Yet even before the object emerges, before we know whether it is a comet or a craft, humanity is already beginning to feel the weight of the answer. Because if the unthinkable happens, if 3i Atlas shifts course or reveals signs of control, the discovery will not simply belong to astronomy, it will belong to everyone. And that, Avi Loeb warns, may be the greatest challenge of all. He said it clearly during a recent conference. Asterisk, if this is another intelligence, our reaction will determine the first impression they have of us. Asterisk, it's a haunting thought that the universe might already be watching how we respond. If 3i Atlas truly is an artifact, an engineered object from beyond Earth, then the discovery will trigger the most profound paradox in human history. The moment we finally learn that we are not alone might also be the moment we realize how unprepared we are for that truth. Psychologists call it a crisis of meaning. Religions might call it revelation. Economists might call it collapse. For centuries, our civilizations have been built upon a single unspoken assumption that humanity is the center of awareness, the measure of intelligence, the top of the cosmic hierarchy. If that assumption falls, every structure built upon it begins to tremble. The first impact would not be physical, it would be spiritual. Temples, churches, mosques, the institutions that have guided humanity's relationship with the unknown, would face questions deeper than any doctrine could answer. Some might embrace the revelation as proof of divine creation. Others might see it as contradiction. For the faithful, the discovery of another mind might expand the concept of God. For the fearful, it might diminish it. Avi Loeb, who often speaks not just as a scientist but as a philosopher of reality, once said, asterisk, science and religion share the same root, the desire to understand our place in the universe. The only sin is arrogance. Asterisk. And arrogance, perhaps, is what this discovery would finally strip away. But beyond faith lies another kind of faith. The faith we place in systems, in governments, in markets, in order. That faith too would be tested. Economists have modeled what would happen if proof of extraterrestrial intelligence were confirmed. The numbers are grim. Markets rely on predictability, and nothing is more unpredictable than the appearance of a superior technology or intelligence. Stocks would plunge, currencies would spiral, investment would freeze. Humanity's carefully balanced networks of trust would unravel overnight. The reason is simple. The unknown destroys stability. It is the same reason why whispers of war can move billions of dollars in seconds. Now imagine the rumor that we are not alone. Some predict panic, others predict unity. Both might be true. For a few days, chaos might reign, governments withholding information, media outlets competing for control of the narrative, citizens demanding answers no one is ready to give. But then, slowly, another realization would rise. That this moment, terrifying as it is, connects us more deeply than any event in history. No nation owns the sky, no border can contain the cosmos, and in that shared uncertainty, a fragile kind of unity might emerge. Still, power resists surrender. The geopolitical consequences of confirming alien technology would be immense. Every government would want access to the data, the technology, the potential advantage. Military alliances might fracture. Old rivalries could reignite under the banner of defense or discovery. The very idea of control of who speaks for humanity would become the next great debate. Avi Loeb has argued for transparency above all else. Asterisk, the sky belongs to everyone. Asterisk, he said. Asterisk, no one has the right to hide the universe. Asterisk. It is both a moral and a scientific statement. Because in an age when truth can be shaped by politics, the only safeguard for knowledge is openness. Yet history tells us that openness is the first casualty of fear. Imagine the first confirmed image of an artificial object in space, broadcast to billions. Within hours, every ideology on Earth would rush to define it. For some, it would be a sign of hope. For others, a threat. For the powerful, it would be an opportunity. The paradox, then, is not just external, it is within us. We yearn for discovery, but fear what it will undo. We long for connection, but distrust what we do not control. And yet, perhaps this is the lesson the universe has been trying to teach all along, that we are not meant to dominate the cosmos, but to listen to it. Loeb often reminds his audiences of something simple yet profound. Asterisk. Curiosity is not a weakness. It's the universe trying to understand itself through us. Asterisk. If that is true, then perhaps the greatest danger is not the existence of another intelligence, but the possibility that we will fail to respond with our own, because how we meet the unknown will define not just our science, but our soul. In this way, the true first contact will not happen through radio signals or spacecraft, but through our reaction, through the way humanity chooses to face its reflection in the cosmic mirror. Will we meet it with fear or with wonder? Even now, world leaders quietly convene. Religious scholars draft statements about life beyond Earth. Economists simulate worst-case scenarios. Psychologists prepare for what they call ontological shock, the collective disorientation that comes when the foundation of meaning dissolves. And yet, amid all this preparation, there is something deeply poetic about the uncertainty. For the first time in generations, the entire planet is looking in the same direction, waiting for the same answer. That unity, born of mystery, may be the beginning of something greater than panic or power. It may be the beginning of humility. Loeb has said, asterisk. We may not be the only actors in the cosmic story, but that doesn't make our role less important. It makes it more meaningful. Asterisk. In the end, the paradox of 3I, Atlas, may not be about aliens at all. It may be about us, about how fragile our sense of control truly is, and how extraordinary it is that we can still choose curiosity over fear. Because if we learn that we are not alone, it will not end the human story. It will expand it. It will turn our small blue planet from the center of everything into part of something vast and connected. And maybe, when that realization finally comes, we'll understand that the greatest discovery was never about finding intelligence out there, but about awakening it within ourselves. Look up at the sky, Avi Loeb once said, asterisk, because something might be looking back, asterisk. And perhaps that is where this story truly ends or begins. As November unfolds and 3I Atlas emerges from behind the sun, all of humanity waits in quiet suspense. Will it move like every other comet we've known, following its silent, predictable path? Or will it do something no object should do, something deliberate, something intelligent? Whatever happens, the answer will not only tell us about what is out there, but also about who we are down here. Because every time we raise our eyes to the night, we are also looking inward into our own hunger for meaning, our fear of the unknown, and our endless capacity for wonder. If this is merely a comet, then we've once again glimpsed the strange poetry of nature. But if it is more, if this is the first moment of contact, then it will mark the dawn of a new chapter for our species, one written in both awe and responsibility. Either way, the act of looking up changes us. So tonight, let yourself wonder. Step outside, feel the cold air, and remember that above you, something ancient is gliding through the dark. And if you want to keep following this story, to stay awake with us beneath that infinite sky, subscribe to the channel. Together, we'll keep listening, keep searching, and keep asking the question that defines us. What else is out there, waiting to be seen?